Hello everyone, welcome back to my presentation number 2. Okay, number 1 was all about my introduction and some few questions in which we discussed about how to find the LCM of two numbers, the HCF of two numbers, and also we discussed about multiples of a number, and also we discussed about factors of a number by different many methods. Now for this presentation, I will just continue from where we ended. Okay, without further ado, now let us continue. We start with this question over here. This question is talking about Mia. The question says, Mia has a large bag of sweets, and Mia says, if I share the sweets equally among 2 people, 3 people, 4 people, 5 people, or 6 people, there will always be 1 sweet left over. Now the question is, what is the smallest number of sweets there could be in the bag? Okay, so here the question or the terminology which we have to focus on is this terminology here, the smallest number of sweets. So the word smallest is equivalent to the word lowest. And remember, we discussed about lowest common multiple in our previous video, lowest common multiple. So the question is, what is the smallest number of sweets there could be in the bag? So what we do, in other words, we are supposed to find the LCM of this number of people. We have 2 people, 3 people, 4 people, 5 people, and 6 people. So we're supposed to find the LCM of 2, 6, 4, 5. Sorry, let me arrange the numbers properly. Find the LCM of 2, 3, 4, 5, and 6. We have 1, 2, 3, 4, 5 numbers. Okay, now I explained to you about 3 methods of finding the LCM of numbers, and here I will go for one of the methods, which we call it prime factorization. So I'm going to use this method to work out the LCM of 2, 3, 4, 5, and 6. So I'm going to use prime factorization. Now, if you want to know how is this method done, stay tuned over here. I'll do it for you. So you put all the numbers over here, 2, make a boundary, 3, make a boundary, 4, 5, and 6. And then you start looking for the smallest possible prime numbers. So this is divisible by 2, so 2 divided by 2 is 1, 3 divided by 2 leaves a remainder, so copy and paste 3, 4 divided by 2 is 2, 5 divided by 2 leaves a remainder, copy and paste 5, 6 divided by 2 is 3, keep going, go by 2, 1 divided by 2 is a decimal, so copy and paste 1, 3 divided by 2 leaves a remainder, copy and paste 3, 2 divided by 2 is 1, 5 divided by 2 leaves a remainder, copy and paste 5, 3 divided by 2 leaves a remainder, so copy and paste 3. No possibility of dividing by 2, so go for a 3, 1 divided by 3 leaves a remainder or gives a decimal, so copy and paste 1, 3 divided by 3 is 1, 1 divided by 3 gives a decimal, copy and paste 1. 5 divided by 3 leaves a remainder, and copy and paste 5. 3 divided by 3, 3 divided by 3 is 1. Correct. So this will go for 5. Make the borders clearly. 1 divided by 5 leaves a decimal, leaves a remainder. Copy and paste 1, copy and paste 1, copy and paste 1, but 5 divided by 5 equals 1. So when you get everything equal to 1, then you stop. Now for LCM, like as we discussed earlier, you multiply these numbers. Here we go. So the LCM will be equal to 2 times 2 times 3 times 5. This gives you 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So far so good. So now let us go back to the question. If I share the sweets, Mia says, if I share the sweets equally among 2, 3, 4, 5, or 6 people, there will always be 1 sweet left over. So the question is, what is the smallest number of sweets that could be in the bag? So since there is 1 sweet left, whenever this smallest number of sweets is distributed among those people, so the smallest number of sweets in Mia's bag, the smallest number of sweets in Mia's bag will be equal to 60. This answer we got here plus 1 extra sweet that always remain in the bag. Here we go. There will always be 1 sweet left. So you take this number, or this LCM 60 plus 1, you get 61. So the smallest number of sweets will be equal to 61. Now let us say, let us try to check. Let us try to check if our answer is correct. Okay, so let us say Mia shares 61 sweets among 2 people, for example. So 61 divided by 2, that is 30. 30 times 2 is 60. So what is the remainder? The remainder is 1 sweet. Okay. Let us say 61 shared among 3 people equally. 61 divided by 3 will be, that comes 20. 20 times 3, this is 60, and the remainder will be 1 sweet. Carry on with those 61 sweets shared equally among, say, 4 people. 61 divided by 4, this would be 15. 15 times 4, this would be 60. 1 sweet remaining. 61 divided by, shared equally among 5 people. 61 divided by 5, this comes to 12. 12 times 5 is 60. The remainder is 1. Do the same. 61 divided by, or 61 sweets shared among 6 people equally. That comes to be 10. 10 times 6 is 60. When you subtract that, you get 1 sweet remaining. So the smallest number of sweets that Mia has in her bag is equal to 61 sweets. Okay, that marks the end of the solution to this question, and we are good to go to next question, and that is on this page here. The LCM of 2 numbers is 40. Okay, we are talking about 2 numbers. Now the LCM is 40. One of the numbers is 5. what is the other number. Okay, let us do like so, put like margins over there. Now what we do, we say, let us assume that x is the other number. X is the other number. Okay, now if we go with this assumption that x is the other number, so we are going to have the first number, one of the numbers is 5, and another number is unknown, okay, is x, another number is x. Now what we do is, you should be very careful over here. You know the procedure of finding the LCM by prime factorization. Here we look for the number that divides both 5 and x. Now to start with, you start with numbers. Okay, you start with numbers. You see that 5 is divided by 5. So 5 divided by 5 is 1. X divided by 5. Just copy and paste x over here. And then go for the letters. So 1 divided by x, 1 divided by x, copy and paste 1 over here. But when it comes to x divided by x, set that as a fraction. X divided by x, you find that x and x is cancelling, so the answer equals 1. So x divided by x, the answer equals 1. So like as we discussed earlier, when you get when you reach to this stage where you remain with only one over here, so that is where we stop for prime factorization. Now, how do we calculate the LCM? Like we discussed earlier, the LCM over here will be calculated by referring to these numbers here. Okay, that we normally say LCM equals to multiply these numbers, multiply those numbers. So what is 5 times x? 5 times x is 5x. But remember, the LCM is given. The LCM is here. The LCM of two numbers is 40. So in place of LCM, you write 40 equals to 5x. Now, how do we find the value of x? Okay, so here we are trying to figure out, the value of x. So we have 40 equals 5x. Now to find the value of x, you simply divide by 5 over here. Simply divide by 5 on both sides. This 5 will cancel. So 40 divided by 4. So this we divide by 5 on both sides. Divided by 5, divided by 5. So 40 divided by 5, this will be 8 equals to the other number. So here, in conclusion, we say the other number is 8. The other number is 8. Correct. So let us move on. Now this time they are talking about the HCF of two numbers. Okay, we discussed about the HCF previously, and we had something like 3 methods on how to find HCF. I will choose only one method, and we are good to go. All right, so far so good. We have this one. The highest common factor of two numbers is 8. One of these two numbers is between 20 and 30. Oh, okay. So they are talking about the highest common factor of two numbers. Okay, so let us find what are those two numbers. Okay, now it is mentioned here that one of the numbers is between 20 and 30. So one of the numbers is between 20 and 30. So let us try to identify all numbers which are between 20 and 30. Okay, guess what? We are going to have 21, 22, 23, for numbers between 20 and 30, 21, 22, 23, 24, 25, 26, 27, 28, 29. Then stop over here. So one of the numbers is between 20 and 30. Okay. The other number is between 40 and 60. Okay. So the other number is between 40 and 60. We're going to have plenty of numbers over there because that looks to be a bigger range of numbers, but never mind. The other number is between 40 and 60. Those numbers are the numbers between 40 and 60 include 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, and stop there. Okay, now how do we use this concept over here? The highest common factor of two numbers is 8. So the question is, what are these two numbers which have the highest common factor equal to 8? So what we do, we have just identified the numbers which are between 20 and 30, and we have also identified numbers between 40 and 60. So the next task is to, from this list here, we have to identify all the numbers which are divisible by 8. So starting with the first list here, let us identify all the numbers from this list which are divisible by 8. Okay, 21 is not, 22 is not, 23 is not, 24 is divisible by 8. 25 is not divisible by 8, 26 is not divisible by 8, 27 no, 28 divided by 8 is not possible, gives a remainder. 29 divided by 8 also is impossible. How about the other set of numbers? Can we identify the numbers which are divisible by 8? The answer is yes. 41 is not divisible, 42 is not divisible, 42, let me check, pull out your calculator and simply do 42 divided by 8. What do you get? You get a decimal, therefore 42 is not divisible by 8, 43 no, 44 no, 45 not divisible, 46 not divisible, 47 no. Oh wow, 48 is divisible by 8. To confirm that, pull out your calculator and do the calculations. 48, check if it is divisible by 8. Yeah, it is divisible by 8. 49 no, 50 is not, 51 no, 52, 53, 54 no, 55, 56. 56 is probably divisible by 8. Let us confirm. 56 divided by 8. Do we get a decimal? No, we get a whole number. 37. Okay, now we have one number in this list which is divisible by 8, but in the other set of numbers we have two numbers. Now the question will be, which of these two numbers will combine with 24 to make the highest common factor of 8. This is how the question says. The question says the highest common factor of two numbers is 8. So one of the numbers, I got it. I got one of the numbers is 24 from the first set of numbers. Now from the second set of numbers, we have two numbers. One is 48, another one is 56. Now we have to choose one. We have to choose one from this list and combine with 24. That will give the highest common factor equal to 8. Okay, we have another question here. List the prime numbers between 60 and 70. That will come later. For now, let us block it so that we can get a space for us to continue with our question. So, okay, I'll paste that. Okay, block this question for now. We'll unblock it later, get a space for that. Now, let us choose, let us find the way how to discover which number among 48 and 56 will combine with 24. So let me use a factor tree to confirm the number. So let us start with 24, for example. What are the factors of 24? This goes by 2 is 12. This goes by 2 again. By 2 this 6, and lastly this 2 times 3. So 24 will be equal to 2 times 2 times 2 times 3. Okay? When it comes to 48, we have 2, 24 here, we have 2, this is 12, we have 2, this is 6, and lastly we have 2 times 3. So for 48, this will be 2 times 1, 2, 3, 4, 1, 2, 3, 4, 2, 2, 2, 2, there are 4 of them, then times 3. Okay, now let us pause here and find if the HCF will be equal to 8. Let's find out if the HCF of 24 and 48 will be equal to 8. Okay, for HCF, we look for common factors. 2, 2 is common, so put it there. 2, 2 is common, put it over there. 2, 2 is common, put it over here. 3, 3 is also common, put it over here. Now let us see if the HCF will be equal to 8. It's going to give you 8. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So 24 is not equal to 8. So what? That implies 58 is not one of those two numbers. So that will automatically indicate that 56 is the number which you are looking for, but we cannot confirm it as easily as that. Let us repeat the exercise. But since we have two numbers, and if you are in the examination room, you could have picked 56 because you have 48 and 56 from which you have to make choice. So 48 is not giving the HCF of 8, so automatically 56 will be the number. But for the sake of practice and demonstration, let me do for that. So we have 56. Do a factor tree for that. This will be 2 times 28. This will be 2 times 14. This will be 2 times 7. Stop there. So for 24, we got 2 times 2 times 2 times 3. And for 56, we have 2 times 2 times, how many 2's? How many 2's are here? 2 times 2 times 2, there are 3 2's. And lastly, times 7. Now let us see if the HCF will be equal to 8. Okay, To do that, HCF stands for highest common factor. We find that 2 and 2 is common. Cancel that. Record it over here. 2 and 2 is also common. Cancel those common factors. Record them there. 2 and 2 is also common. Put it over here. 3 is not common. 7 is not common. So it remains 2 times 2 times 2. And that is 8. So what is the conclusion? The conclusion is with the reference to the question, what are the two numbers? So here you write the two numbers are one we got 24, another one we got 56. Those are two numbers they're talking about. So far so good. Okay, now remember there is one question we blocked. Let me unblock that question and then we'll continue with that question. Okay, so let us lock that in place. And then we want to copy this. So that. Sorry for the delay, but this is the learning process which one should not avoid. Group that. Good. So we have this. Okay, here we go. Now this is the question which we blocked. List the prime numbers between 60 and 70. I was in my previous videos, I introduced about what do we mean by saying prime numbers. Okay, so prime number, a number is said to be prime if it has two factors. Okay, and that must be two factors of that number should be 1 in itself. So the question here is list the prime numbers between 60 and 70. Okay, so let us try 61, for example. Is this number between 6 and 70? Yes, 6 and 70. Okay, 62, is it between 6 and 70? Yes. 63, yes, between 6 and 70. 64, yes, is between 6 and 70. 65, yes, is between 6 and 70. 66, yes. 67, yes. 68, yes, is between 6 and 70. Then 69. But the question is, just select from this list which numbers are prime. Okay, which numbers are prime? 61, yes, 61 is divisible by 1 itself, so 61 is a prime number. 62, no. 63, no, is divisible by more than two factors. It's divisible by 1, yes, it's divisible by itself, yes, it also is divisible by 9. 63 divided by 9 is equal to 7. 64, no. 65, no. 66, no. 67. 67, yes, this is a prime number because it happens to have two only factors. 68, no. 69, no. So we have two of them, 61 and 67 are prime numbers. Prime numbers between 60 and 70. Okay, that sounds great. 31 is a prime number. What is the next prime after 31? This is the second. This is the next question. 31 is a prime number. What is the next prime number after 31? Okay, after 31 comes, let me check. After 31 comes 32. Now the question is 32 a prime number? Nope. After 32 comes 33. Is 33 a prime number? No, it's not a prime number. After 33 comes 34. Is 34 a prime number? No. How about 35? 35, no. 36, is this 36 a prime number? No. 37, yes. So the prime number after 31 is 37. So far so good. 31 is a prime number. What is the next prime number after 31? That is 37. Okay, so I don't see any other question on this page. Let us head on to the next page. Okay, this page is talking about two people. Okay, these people are trying to argue that the first person says 91 is a prime number. Another person says 91 is not a prime number. Now the question is, who is correct? And give your reason. Give a reason for your answer. Okay, like as I said earlier, a prime number is any number which has two factors, only two factors. Now if we check for factors here, let us see the factors of 91. If it happens that 91 has only two factors, therefore 91 would be a prime number, and therefore this person over here will be correct. If it happens that 91 has more than two factors, this person here will be correct, because she's the only one who is saying 91 is not a prime number. Okay, let us see the factors of 91. If they exist only two factors of 91, then we are going to conclude that 91 is a prime number, otherwise not. Okay, factors of 91. I said 1 is a factor of every number. So when you do 91 divided by 1, the answer is 91. Go to 2, 91 is not divisible by 2. Go to 3, 91 is not divisible by 3. Go to 4, is not divisible. Go to 5, not divisible. Go to 6, not divisible. Try 7. So take your calculator and do 91 divided by 7. Okay, so 91 is divisible by 7. The answer is 13. So you can see that 91 has more than two factors. So who is correct? Alicia is correct. So Alicia is correct. So here you say, who is correct? The answer is Alicia is correct. Why? Give reason. Okay. 91 is not a prime number, according to Alicia, and we agree that Alicia is correct. Now, give a reason. So, 91 is not a prime number. Is not a prime number because it has more than two factors. It has more than two factors. Remember, prime number is said to be I mean, remember that a number is said to be prime if a number is said to be prime if it is divisible by 1 and itself. Full stop. All right, so far so good. Let's go to more about prime numbers. Okay, what do we do here? This has been explained earlier on how to find LCM by using a factor tree. So this, you don't have to waste your time, but there is a remark here. There's a remark here. Check that these are correct. You have 60 equals to 2 power 2 times 3 times 5, and we have 75 equals to 3 times 5 power 2. Now we want to check if they are correct. So what we do, like as I said earlier, just make a factor tree for 60 and see how it goes. Okay, so we have a factor tree for 60. This is 2. 60 divided by 2 is 30. 30 divided by 2 is 15. And this goes by 3 times 5 is 15. Now, how do we write that? We write 60 equals to, how many 2's are there? We have 2 2's. How many 3's are there? We have 1 3 and we have 1 5. But in principle, you can write these as a power of 2. So this would be 2 power 2, meaning that 2 times 2, meaning that there are 2 2's. Okay, then times 3, because there is 1 3, times 5, there is 1 5. So the question is, check that these are correct. So we conclude by saying that this is correct. Okay, how about 75? 75, pull it over here. 75, is it divisible by 2? No. By 3, yes. That comes to be 25. And this will continue getting broken into small factors. And this is 25 divided by 5. That will be equal to 5. Okay, so how do we conclude that? 75 equals to 3 times 5 times 5, and this will be equal to, there is 1 3, so it remains like that, but there are 2 2. When there are 2 5's, this will be 5 to the power of 2, and the question was to check that these are correct. So this is correct. Okay, now what have we done here? And what have we done over here? Basically, we have written 60 and 75 as a product. As a product of its, as a product of their prime factors, as a product of their prime factors. So there are some questions which usually come in the exam, that can you write 60 or any other number as a product of its prime factors. So this is the way how we do that: 2 times 2 times 3 times 5, or you can also write it as 2 squared times 3 times 5. This number over here indicates that we have 2 2's. Okay, so this is what we do if the question comes, like to write the number 60 as a product of its factors. Okay, the same applies to 75. We got something like so. 3 times 5 times 5, and this is shortened to 3 times 5 to the power of 2. So this is answering the question, which usually comes in the exam, that write the given numbers as a product of its prime factors. And this marks the end of this page. Okay, so let us go to the next page over here. Now then, this page is talking about how to find the LCM of two numbers, even more than two numbers, using the concept of the product of prime factors. And we have done this, how to find the LCM of two numbers, even more than two numbers. We discussed this earlier, but quickly we can check if the LCM of 60 and 75, we can check if the LCM of 60 and 75 equals 30. Okay, so without further ado, let us see that. We have seen that 60 equals to 2 times 2 times 3 times 5. This is what we have recently covered. And also we have seen that 75 equals to 3 times 5 times 5. Okay, now for the LCM, we discussed in our previous videos that for the LCM we look first for the common factors. Okay, over here a 2 is available in 60, but we don't have a 2 in 75. Okay, now let us start with common factors. You find that 5 and 5 is common, so you record it over here, times, when it comes to this 5 is available in 75, but we do not have any other 5 in 60. Okay, so once we are done with the common factors, then we go for the factors which are not common. And these include 2, we ring them, put it over here. Also this 2 is not common, put it over here, times, okay, wow, this 3 is common, so put it over there. And how about this 5? This 5 is not common, so just ring that and record it over here. Let's calculate the answer. 5 times 2 is 10, 10 times 2 is 20, 20 times 3 is 60, 60 times 5 is 300. So the LCM of 60 and 75 is correct, it's 300. Okay, this is asking for the, let us check if the HCF of these two numbers, 60 and 75. Let us check if the the HCF of 60 and 75. Let us check if it is equal to 15. Okay. How do we check that? There are three methods I explained earlier, but for now let us use one of the methods, and this is the factor tree. We have seen that 60 equals to 2 times 2 times 3 times 5. Okay. We also saw that 75 equals to 3 times 5 times 5. If you find that there are some steps which you don't understand here, it's better you refer to, or it's better you quickly rush to my previous video, or my first video, which we call it Numbers Part 1. Then you will see everything being explained over there on how to find the LCM using 3 different methods. Also how to find the HCF using 3 different methods. But for now, we are just applying the basics which we have discussed earlier in the video number 1, which is Numbers Part 1. So without wasting time, here we go. For the HCF, we look for the common factors. HCF, we look for common factors. It's different from LCM, where we take everything regardless of being common or uncommon. So HCF will be equal to look for the common factors. Okay, 3 and 3 is common, record it over here. 2 is not common, 5 isn't common over here, so you record that. How about this 5? We do not have another 5 in here, so this mark is not going to be common. Also, we don't have 2 in 75. Also, we don't have this 2 in 75. So for HCF, we look for common factors, and these are 3 and 5. Then when we multiply them, that will be equal to 15, and this will be the HCF of 60 and 75. So this answer was correct. So far, so good. There is another question here. This question says, match each number to a product of primes. Oh wow, we discussed about this. Match each number to a product of primes. One has been done for you. Okay, but let us check if it is correct. 20. So how did they get? How did they get 2 power 2 times 5? This is by using what we discussed. This is by using a factor tree. So let us see a factor tree for 20. This is 2 times 10. This is 2 times 5. We'll stop there because all these numbers we have got are all primes. So how do you write the answer? So 20 will be equal to 2 times 2, 2 times 2, and later times 5. How do we shorten this? 2 times 2 indicates that we have 2 2's over here, so it will be 2 power 2, and times 5. So this is correct. Okay, this is correct. This is correct. Now let's go to the next number. It's 24. So 24, pull out a factor tree for 24. This will be 2 times 12. This will be 2 times 6. And this will be 6 can be further broken down. This will be 2 times 3. So neither 2 nor 3 will not be further broken. So 24 in short will be, how many 2's are here? 2 times 2 times 2, 2 times 2 times 2, 10 times 3. That in power form will be, how many 2's are here? We have 3 2's. So this will be 2 to the power 3 times 1. Times 3, because there is 1 3 over here. So this will be 2 power 3 times 3. So we just come back here and then we see how we can match that. 24 matches to, let me check properly and see which kind of line we can pull for 24. 24 we got 2 power 3 times 3. 2 power 3 times 3 is over here. So you match that like so. Then you go for 24 is done. 42. Okay, 42. Okay, let us do it over here. 42. Okay, and put it normal like so. So 42. 2 times 21. 3 times 7. So for 42 we have 2 times 3 times 7. 42 we have 2 times 3 times 7. Do we have that? 2 times 3 times 7. We have that solution. So pull it here. 42 is okay. 42 is going to match with 2 times 3 times 7, which is over here. Okay, so far so good. Then we go for 50. Okay, for 50 we do the same thing. 50, do the factor tree for 50. This will be 2 times 25. and this will be 5 times 5. So in other words, 50 equals to 2 times 5 times 5. Or as a power, this will be 2 times 5 to the power of 2. Do we have that answer? 2 times 5 to the power of 2? Yes, we do. We do have that answer. And 50 matches with 2 times 5 times 5. And there we go. Now, we have one number, 180, and we have only one choice remaining. So automatically this will be matched like so, because we have one left, one choice is left on the left hand side and another choice is left on the right hand side. So we just save time by matching it straight away. But suppose you want to check that if your match is correct. So we have 180 over here. Do the factor tree for that. 2 times 90, and then this will be 2 times 45, and lastly this will be, not lastly, we have some few steps over here. 45, 3 times 15, and then you do 3 times 5. See that? So it will be 2 times 2, then 3 times 3, then times 5. So we have 2 2's, and we have 2 3's, and 1 5. So 2 2's, this one here, 2 3's is here, and 1 5. So our match is correct. That marks the end of that question, and also it marks the end of the page. Okay, quickly, let's go to this one here. What is the question talking about? Write each number as a product of primes. Okay, this is what I talked before. Write each number as a product of primes. We have Loman 1, 45, and we have Loman 2. This is talking about Loman 1 is 45, and Loman 2 is 75. So how do we do that? Use factor tree. So write each number as a product of primes. We start with Roman 1. Just do the factor tree for 45. This goes by 2 now. This goes by 3, 15. This goes by 3 again. This makes 5. 5 is 15. So as a product of its primes, because every number you see here, these are what we call the primes, or the prime numbers. Okay, so write it as a product of primes. So that will be 3. Sorry, that will be 3 times 3 times 5. Or someone can say there are 2 3's, so you can write 3 or 2 times 5. How about 75? Do the same thing. Pull out your factor tree for that. This begins with 2, no, begins with 3. That comes 25, because 3 times 25 equals 75. Then you go for 5 times 5 is 25. So this will be equal to 3 times 5 times 5. But as a form of power, we have 1 3, but over here we have 2 5s. So this will be 5 to the power of 2. So either way, the answer will be correct. Find the LCM of 45 and 75. We already know the product of. We already know each number has been expressed as a product of its primes. So let us take advantage of those prime numbers. Primes. This we got for 45. We got 3 times 5. We got 3 times 3 times 5. And for this one, we had 3 times 5 times 5. Okay, being the LCM, we look for common factors first. That is 3 times, so this is common, times 5. And then we go for uncommon factors. 3 is uncommon, and also 5 is uncommon. So when we multiply all this will be 3 times 5, 3 times 5. So 3 times 5 is 15. 3 times 5 is also 15. So 15 times 15, 15 times 15 is 225. You can check that using a calculator. That let me put my calculator over here. Cool. So 15 times 15, the answer is 225. So you can check that using your calculator for LCM. For HCF, we do the same thing, because HCF stands for common factors, highest common factors. So for 45, we had 3 times 3 times 5, and for 75, we had 3 times 5 times 5. Now, what is the HCF? The HCF is so easy to do, because for HCF we just look for common factors, only for common factors. But for LCM, we look for both common and uncommon factors. So this, for HCF, look for common factors. This is 3, this is common, also 5 is common. Do you have another common factor? We have 3 over here. We do not have any 3 remaining here, so 3 is uncommon. We have 5 here, but we do not have any 5 pending, so this 5 is not common. So what do we do if we have got only these? We multiply them. 3 times 5 gives you 15. So the HCF of 45 and 75, from the concept of prime factors, the HCF is 15. So far so good, and this marks the end of that page. Okay, how about this one? Okay, write each number is a product of primes. Same concept. We have 90. Do the factor tree for that. We have 140 because to express each number as a product of primes, we need what we call a factor tree. For each number, a factor tree. So starting with 90, this will be 2 times 45. This will be 3 times 15. And this will be 3 times 5. See that? So as a product of its primes, do 2 times 3, 2 times 3 times 3 times 5. So far so good. For 140, we do the same thing. So put 140 over here. It's 2 times 70, 2 times 35, 5 times 7. So this will be 2 times 2, 2 times 2 times 5 times 7. Okay, 2 times 2 is 4, times 5 is 20, times 7 is 140. So write each number is a product of primes. This also you can put as a concept of power. 2 times 3 to the power of 2 times 5. The same applies over here. We have 2 2's. So 2 to the power 2 times 1 5 times 1 7. Okay, so far so good. Find the LCM of 90 and 140. Okay. From here, from this product of primes, we have to rewrite them. This is 2 times 3 times 3 times 5. And we have to do the same for 140. it is 2 times 2 times 5 times 7. For LCM, we look first for the common factors. So when 2 is common, cancel that. 2, we don't have another 2, so we leave that. Yes, we have 5 is common, do that. And then we look for factors which are not common. One of them is 3. Record it over here. Another one is 3. Record it over here. Another one which is not common is 2. Put it over here. Times last 3. This is 7. Let me check properly. 2 goes here. 5 goes there. Those are common factors. Then we go for uncommon. We have these 2 3s and 1 2 and 1 7. So we're good to go for LCM. 2 times 5 is 10. 10 times 3 is 30. 30 times 3 is 90. 90 times 2 is 180. 180 times 7. 180 multiplied by 7. That gives you 1260. 1260. You can check that again. Is 2 times 5. 2 times 5 is 10. 30. 90. 90 times 14, for example. That is another way. Yes, we get 1260. Okay, how about the HCF of 90 to 140? Okay, rewrite. You have to rewrite the product of the primes. So we have 2 times 3 times 3 times 5, and we have 140 over here. We have 2 times 2 times 2 times 2 times 5 times 7. Okay, good. So that will be for the HCF. For the HCF, like how I said before, is simple. HCF is simple. Look for common factors and leave out those which are not common. So 2 is common. Do that. We have another 2. We don't. 5 is common. Times 2 over here. No. 7. No. 3. No. 3. No. So you will be simply multiplying 2 by 5. So 2 by 5. It is 10. This is the HCF of 90 and 140. That marks the end of that page. Okay. Now, let us move on to powers and roots. Powers and roots. So, by definition, what does a power mean and what does a root mean? Okay, we say a number multiplied by itself, several times is called a power. The power of that number. And you use indices to show powers. I will explain you all that. Okay, now you are already familiar with what we call a factor tree. Okay, now let us see a factor tree for the number 25 and see how we can reach to this power over here. So 25, the factor tree is looking like that. 5 times 5 is 25. So how many 5s are here? We have 2 5s. And that is why we write from 5 to the power of 2. So 25 is a number. When we write 25 is a power of 5, this will be the answer, 5 to the power of 2. And this concept over here comes from what we call the factor tree. Likewise, we have 125. Do the same thing. You have 125. Do a factor tree. This is divisible by 5. 5 times 25, and this is also divisible by 5. So it's 5 times 5. So how many 5s are here? We have 3 5s. Because of that, in a power form, you write 5 to the power of 3. 5 to the power of 3 is this one over here. So 125 as a power of 5 will be 5 to the power of 3. And this concept over here, 5 times 5 times 5, is simply obtained from a factor tree. Okay, now you may be going in that process, and you can pause a video and see how you can get this out of 625. Okay, but for those who would like to continue with me, you have 625, and you do this is divisible by 5. This comes to be 125, and this is by 5. This is 25. Keep going. This is 5 times 5. So how many 5s are here? Find that we have 1, 2, 3, 4 5s. So we have 1, 2, 3, 4 5s, and that is a power of 5. That would be 5 to the power of 4. So this comes from the factor tree. Okay, now you can try that and see if this is correct. And if it is not correct, please let me know. Leave a comment below this video that this product is not correct. But you have to use a factor tree to verify that 3125 is equal to 5 to the power of 5. As simple as that. So you can try that at your own time and come to conclude that 3125 equals to the 5 to the power of 5. Alright, so far so good. Let us see some other categories of powers. Good. Now, somebody can ask you, what is the square of 5? What is the square of 5? So the square of 5 is written as 5 to the power of 2. And remember what we discussed? We said that 5 to the power of 2 means 5 has been multiplied by itself 2 times. That is what it means. And 5 times 5 gives you 25. Okay, now what is, okay, this was all about the square of 5. The square of 5. The square of 5 is equal to 25. Sorry. The square of 5 is equal to 25. Now somebody can ask you, what is the square root? What is the square root of 25? The square root of 25, the square root, the symbol for square root is looking like this. This stands for the square root, the symbol for the square root. Now the square root of 25, sorry for that, the square root of 25 means which number multiplied by itself gives you 25. That number is equal to 5. So in other words, we say the square root of 25 is equal to 5. What is the reason? Because 5 times 5 equals to 25. So the square root of 25 is equal to 5. But is it true that the square root of 25 is only equal to 5? Is it true that we don't have any other number which when multiplied by itself gives you 25? Yes, we do have that number, and that number is negative 5. So the square root of 25 is equal to 5 and also negative 5. Now, why negative 5? Because Negative 5 times negative 5 gives you positive 25. Remember our discussion? Negative times negative gives you positive. 25 times 5 is 25. So square root of 25 equals to 5 and negative 5. So 25 has two square roots. These are 5 and negative 5. The reasons have been explained over here. These are the reasons that why square root of 25 equals to 5. We have said because 5 times 5 equals to 25. And also we have tried to reason why square root of 25 is equal to negative 5. Because we said negative 5 times negative 5 also will give you 25. Cool, yeah? Good. After the concept of the square of a number, let us see another concept which we say a cube of a number. A cube of a number is obtained when we take that number multiplied by itself 3 times. You know what it means? For example, if we are talking about the cube of the number 5, how do we find the cube of 5? The cube of 5 means take 5 multiplied by itself 3 times. See that? 5 times 5 is 25. 25 times 5 is 125. So you know what it means? The cube of 5 is 125. And this is the way how we work out the cube of 5. Okay. What if they ask you the cube of negative 5 is equal to how much? Correct. The cube of a number, you take that number multiplied by itself 3 times. That is how we figure out the cube of a number. Now in this case we have the cube of negative 5, and this is negative 5 times negative 5 times negative 5. Now to figure out this, let us talk about the signs. Negative times negative is positive, negative times negative is positive, and positive times negative equals to negative. Now negative how much? The same applies here. That 5 times 5 is 25, times 5, that is 125. So what is the cube of negative 5? The cube of negative 5 is negative 125. Whereas the cube of positive 5 is positive 125. And this becomes the working for that. So far so good. That marks the end of this page, and that will give us the chance to come and discuss this page. Okay, now we know how to find the square of a number. Now we know how to find the square of a number. Okay, and also we know how to find the square root of a number. Now this page, on this page, we will be talking about how to find the square numbers, how to find the square numbers and their square roots. Okay, the square numbers. Okay, now in this column over here, they are talking about the first 20 square numbers. Okay, the first 20 square numbers. And in this column, we'll be looking for their corresponding square roots. How do we get how do we get square numbers? And they are saying the first 20 square numbers. Okay, for demonstration purpose, I will be writing the position number of such a square number. So if I'm looking for the square, if I'm looking for the first square number, what we basically do is you take the position, which is 1, multiply by itself, because we are talking about the square of a number. So if you are looking for the first square number, you do 1 times 1, and this gives you 1. If you're looking for the second square number, you look at the position number, which is 2, and multiply by itself. This gives you 4. So if you're looking for the third square number, you would do 3 times 3, and it gives you 9. Now, if you are looking for the fourth square number, you take the position number is 4 multiplied by itself. That gives you 16. So you can pause the video and proceed until you finish up to the 20th square number, or the 21st square number. Okay, if you want to proceed with me, then stay tuned. So if I'm looking for the fifth square number, I will do 5 times 5, and that gives me 25. If I'm looking for the sixth square number, I will do 6 times 6, and get 36. Same continues with seventh square number. I do 7 times 7, that gives you 49. Eighth square number will be 8 times 8, and that is 64. So 64 is the 8th square number. I go for ninth square number is, let me work out that, 9 times 9. So I'm getting 81 is the ninth square number. 10th square number will be 10 times 10 equal to 100. 11th square number will be equal to 11 times 11. That gives you 121. So 121 is the 11th square number. How about the 12th square number? You do 12 times 12. That gives you 144. 144 is the 12th square number. Keep going until you reach to the 21st square number. So go to the 13th square number, do 13 times 13, which gives you 169. That is a square number. Okay, go for the 14th square number. This will be equal to 14 times 14. That will give you 196. If you do 15th square number will basically give you 15 times 15, and that gives you 225. How about 16th? That will be equal to 16 times 16 equals to 256. 17 times 17 gives you the 17th. Multiple, this is 289. 18 times 18, that will give you 324. You can check that using a calculator. 18 square will give you 324, so we are correct. And this will be 19 times 19 will give you somewhere around 361. Nope, let me check. 19 square. Oh, we are correct. 361. How about the 20th square number? Will be 20 times 20 gives you 400. Should have one more space. Yes, for the 21st square number will basically be equal to 21 times 21. This will give you 400. 21 square will give you 441. So 441. Right, now, what are the square numbers now? That is the question. The square numbers are all of these numbers. See those? These numbers are what we call the square numbers. Right, so these numbers over here, put them down like so. All these numbers over here are what we call the square numbers. Okay, right, those are square numbers. Let me highlight them. If at all they ask you, can you write down or can you select the square numbers? So these are our square numbers: 1, 4, 9, 16, 25. All these are square numbers. These are square numbers, and so on and so on. There are plenty of square numbers, and the idea on how to generate square numbers, that depends on the position number of the square number itself. So if you are looking for like say the 60 or 75th position number, that means you take 75 times 75. So all those highlighted over there are the square numbers. Okay, now let us see what are their corresponding square roots. Let me start with this square root of 1. I said square root of 1, you are thinking of a number which when multiplied by itself gives you 1. So that number is 1. Why? 1 times 1 equals 1. And we have another square root for square root of 1. We have another square root that is equal to -1. How about square root of 4? The square root of 4 is, we are thinking of a number which when multiplied by itself gives you 4. That is 2. 2 times 2 equals 4. And -2. Why -2? Because -2 times -2, that gives you positive 4. How about square root of 9? Same thing. Should be 3 and -3. These are two square roots. So every single number, it's the square root. The square root of every single number. We have only two square roots for every single number. Okay, so square root of, say, 16. This will be equal to 4 and -4. And how about square root of 25? Same thing. This will be equal to 5 and -5. Square root of 36 will be equal to 6 and -6. Why? Because 6 times 6 equals to 36. Likewise, -6 times -6 equals to positive 36. Square root of 49, that will be equal to 7 and -7. Square root of 64 will be equal to 8 and -8. How about square root of 81? Square root of 81 will be equal to which number multiplied by itself gives you 81? That number is 9. Because 9 times 9 equals to 81. How about another square root? That is -9. Why? Because -9 times -9 equals to 81. So and so on and so forth. That equals 10 and -10. That will be equal to square root of 121. That will be equal to 11 and -11. Square root of 144 will be equal to 12 and -12. and so on and so on. You can try to pause the video and finish up. Okay, but for sake of knowledge, let us continue. Square root of 169 gives you 13 and negative 13. Square root of 196 gives you 14 and negative 14. Square root of 225 will give you 15 and negative 15. And the square root of 256 will give you 14. Will give you 16 and negative 16. So far, so good. Lastly, we have 289 equals to 17 and negative 17. 324 is which number multiplied itself gives you 324. That number is 18 and negative 18. So it's square root of 324. So the number 324 has two square roots. One is 18 and the other one is 18 and the other is negative 18. Okay, another number is square root of 361. 361 has two square roots. Those are 19 and negative 19. Square root of 400 is 20 and negative 20. Lastly, square root of the square number 441 equals to 21 and negative 21. So far, so good. This marks the end of this page, and for today we can end up here. When we meet next time, I will show you how to generate cube numbers and how to find their corresponding cube roots. But for now, let us stop here and bye for now. Okay, for those who will need like my extra support or my extra help, do not hesitate to contact me through my Skype ID, and that is Zabron.Ernest. This is my Skype ID. This is my Skype ID, whereby this is my Skype ID, whereby you simply post your questions. Okay, then I will make a plan for you, and then we are good to go. Right, so what you do, you simply add my Skype ID in your Skype contacts, and then upload your questions which you would like to discuss with me. Okay, so once you upload your questions to Zabron.Ernest Skype ID, then give me a little time, like 5 minutes, 10 minutes, so that I can prepare a lesson plan for you, and then we are good to start. Now, how does it work? Once I receive your questions or your homework or your past paper questions you would want to discuss with me, once I receive them, once I receive the questions, I normally call you back. Once you respond to my call, then I share my screen. That means you'll be able to see my screen, and you will be able to learn. You will be able to learn maths from the comfort of your home. You don't have to leave your house and then you go or you travel like some kilometers away from your home to reach a maths teacher. You can just reach a maths teacher from the comfort of your home, and that is done through online lessons that I also provide. So Basically, don't leave your home just because you're going to look for maths help out there. Just remember, online lessons for maths are available via Skype. Thank you for now. Bye-bye, and stay tuned for the next other lessons. Thank you very much. Remember to subscribe, leave your comments over there, share, and like my video. Thank you. Bye-bye.